What do we mean by video nystagmography? And then what are the conventions that are followed? We'll deal with the general conventions, and more specifically we'll deal with the balance eye conventions. Understand the terminology. What exactly do we mean by photography? So photography stands for photo means light and graphy stands for writing. So photography basically means writing with light. Now some other more familiar things that we are all used to: electrocardiography. Again, this is writing. That this writing is done by the heart. The writing is done by the electricity of the heart. So there is electrocardiography. And then we have for the eye, there is a investigation by name electronystagmography or ENG. And then what we are presently dealing with, that is video oculography or video nystagmography. So what we mean by video oculography or video nystagmography is there is a writing or a tracing that we get, and that tracing is of the eye and it is obtained from the video of the eye. Just like a tracing obtained from the electricity of the heart is called electrocardiography, a tracing obtained from the electricity of the eye is called electronystagmography, a tracing obtained from the video of the eye is called video oculography. Now what exactly is the mechanism behind video oculography or video nystagmography? Here, if this was the eye center pupil, okay, so we have a method in which the computer can detect what exactly is the center of this pupil. Okay, so when the computer exactly detects the center of the pupil, whichever direction the eye moves, whether the pupil moves along with the eyeball to the right or to the left, whichever side the pupil moves, which the pupil movement actually represents the movement of the eyeball. So the center of the pupil as detected by the computer also moves towards the right or the left. We can use this to obtain a tracing of the eye movement, and that is the principle behind video nystagmography. Into the general conventions of the video nystagmography, let us become familiar with the balance eye user interface. So the balance eye user interface has a top part and a bottom part. The top part has a test selection area, and then there is a test result area, and then in addition to that we also have an area which shows the video of the eye being examined. So in that video area we have an area which corresponds to the right side and an area which corresponds to the left eye. So there is a right eye video and there is a left eye video. Bottom part or the bottom half of the balance eye user interface again is divided by a horizontal line into two parts. There is one area which corresponds to the right eye and there is another area which corresponds to the left eye. For each eye there are tracings which show the eye movement in the horizontal plane, and there is a tracing which shows the eye movement in a vertical plane. The tracings are color coded, and what exactly is the color code of each tracing is shown in a small box on the corner here. So there is going to be a color code, like generally, for example, for the right eye the horizontal tracing is in red and the vertical tracing is in green. Okay, so when we actually look at a video nystagmograph of the eye, we see two tracings for each eye. So one line represents the vertical eye movement, another eye represents the horizontal eye movement. So how do these vertical eye movements trace and the horizontal eye movement trace represent what is happening with the eye. This was to represent the eye. Just imagine that the eye from the neutral position started moving towards the right, stayed on the right for 1 second, then moved towards the left, stayed on the left for 1 second, and then again came back to the right and then stayed on the right for 1 second. How will the tracings, the horizontal tracing and the vertical tracing look on the video nystagmography of this particular eye movement that happened? So the video nystagmography tracing of this particular eye movement will be: the eye started from the neutral position, moved towards the right, up means right on the graph, and then stayed on the right, that is up means right, so stayed up there on the graph for a second. Then left is by convention on the horizontal tracing is down, the graph will come down, stay there for a second. By again convention, it moves up, the graph moves up when the eye moves to the right, and then stays there for a second. So to repeat, the convention for the horizontal tracing is right is up and left is down. So when the eye moves towards the right, the graph moves up. When the eye moves towards the left, the graph moves towards the left. When the eye stays on the left, the graph stays on down, that is represented, left is represented by down, and then graph moves up when the eye moves to the right and then stays there for a second. Okay. So this is the convention when we follow the eye movement in the horizontal plane using the horizontal tracing. In this same person, the vertical trace will look like a flat line because the eye has not shown any vertical movement. What will happen if this eye moved only in the vertical plane? If it moved up, stayed there for a second, then came down, stayed there for a second, and again moved up and then stayed there for a second. Now we'll have to look at the vertical tracing. So what will happen to the vertical tracing? See, the vertical tracing of the eye, here the convention is when the eye moves up, even the graph will move up. So the eye moves up, the graph moves up, stays there for a second. So this is the time graph. Then it comes down. So horizontal axis represents the time graph. So it stays on the down for a second. Then again eye moves up and then stays there for a second. So this represents time. So this is the movement from bottom to top of the eye. So in the vertical trace, the eye movement trace and the vertical trace corresponds to the same directions. When the eye moves up, the vertical trace also moves up. What happens to the horizontal tracing when the eye was doing only a pure vertical movement? The horizontal trace will look flat, will not show any movement. To summarize, every eye movement is represented by two graphs or two tracings. The right eye has two tracings and the left eye has two tracings. The right eye tracing itself will have a horizontal tracing and a vertical tracing. So when the eye is making a pure horizontal movement, only the horizontal tracing will show a significant movement and the vertical tracing will not show any movement. And in the convention is, for horizontal movement of the eye, rightward movement is shown as up and leftward movement is shown as down. Whereas when it comes to vertical tracing, the convention is upward movement will be shown as up and downward movement will be shown as down. So rightward will be up and leftward will be down in case of horizontal tracing. Upward will be up and downward will be down in case of vertical tracing. How will some typical nystagmus patterns look on the video nystagmography? Like for example, if this eye was showing a left beating nystagmus, which means the eye moved very slowly towards the right and had a relatively very fast movement towards the left. So the eye slowly moves towards the right and has a very fast beat towards the left, slow towards the right and fast beat towards the left. So how will the tracing look like? The tracing will look like, so the rightward movement of the trace is shown as upward movement of the trace. So rightward movement of the eye becomes upward movement of the trace. That will be slow and takes a long time on the time axis, and then the leftward movement comes very fast. So slow towards the right and fast towards the left, slow towards the right and fast towards the left. So this is how a left beating nystagmus will look on the, when we look at the horizontal tracing. For a pure horizontal left beating nystagmus will not show any consistent pattern on the vertical tracing, and the vertical tracing will look more or less flat. How will a pure vertical nystagmus look on the graph? Let us take the example of a downbeating nystagmus where the eye moves very slowly towards the up and relatively very fast downwards. So that is the pattern of a downbeat nystagmus. So how does the tracing of the vertical trace look? Okay. So when we look at the vertical trace in this case, it is a downbeat nystagmus. Up on the trace stands for up of the eye. So when the eye is moving slowly towards the up, even the tracing also will move slowly upwards. And when the eye is moving fast downwards, the tracing also will move downwards. So if the vertical trace looks like this, then it is a downbeating pattern of nystagmus. In case of a pure vertical nystagmus, the horizontal tracing will look nearly flat or almost a straight line. How will the oblique nystagmus look? Just imagine the eye is beating upwards and towards the left. Okay, just imagine the direction of the fast component is upwards and towards the left. So how will the tracings look like? So there is a left beating nystagmus and there is a up beating nystagmus. So the horizontal trace will look like it is left beating. So the fast component will be towards the left. That is, fast component on the tracing will be downwards. So there is a slow movement towards the right and there is a fast movement downwards towards the left. Okay, this is how the tracing will look like. So eye is moving slowly towards the right, which means the tracing will move slowly upwards. Eye will move fast towards the left, so the tracing will move very fast downwards. This is how the horizontal tracing will look like. When we look at the vertical tracing of this same eye movement, this oblique nystagmus eye movement, so what will happen here is, so the fast component is a little upwards, so there is going to be a slow movement downwards and fast movement upwards. Eye movement and tracing both correspond in directions. So eye movement will be down, the tracing will be down. Fast movement of the eye is upwards, even the tracing will be upwards. So that is how a typical oblique nystagmus will be represented. So it will have a jerk pattern or a seesaw pattern both in the horizontal tracing and in the vertical tracing. And by just looking at the pattern of this horizontal and vertical tracings, we can actually make out the beat direction of the nystagmus.